Okay. Okay, that means welcome at the last session. I mean the last instructional session, because the next week will be a final exam review, and we will still have a session, which we always remember. The review session are quite important because you have to always have big ears and listen whatever the instructor is saying. It's quite helpful. Okay, but what we still have nice big topic to finalize our calculus 2. That means this is section 10.4. Yesterday, you had an introduction to the polar coordinates, right? I can highlight this, and I can show you something. Do you like this? It's cute, right? That means yes, I found this few years ago probably, and I always show my students. It's like, that's the main, yes, that's the main difference. The Cartesian coordinates are like perpendicular distances. We always write angles, but we not always write, if I can say this way. We like more round shapes, more natural. That means that's actually the polar coordinates. Yes, we're using like the coordinates to describe like different shapes. And before I start, because the section today will talk about the areas bounded by the polar curves. But before I start, I would like to check if you know the basic shapes in polar, the basic curves in polar coordinates. That means I think I will go backwards because I have my other session, which was done by Dr. Bank yesterday. But let's see. I will just test you. Let me switch off the camera, which actually I like when you see me, even if I don't look good. It's better connection. But I will switch off the video. How can I switch off? Okay, that means now the whole screen is. Okay, that means these are circles. That means hopefully you learned yesterday. Okay, we may have a circle. Okay, I need my colors. Have a circle which is placed exactly in the middle. Okay, and then the equation is just simply r equals to a constant, like let's say 2. The distance, yes, for each angle is 2. That we know, right? We know because we're looking for always for the radius and the angle. Okay, that's one thing. Another equation that we may have r equals to a, like any constant, times sine theta. That means when we see sine theta, we will still have a circle, but placed in the first and the second quadrant, because sine is positive in the first and the second quadrant. That means we remember when we have negative values, we never place the values in the negative, we always place in the opposite quadrant. That means if this is, let's say, negative point, we will actually plot on the other side. Okay? That means first and the second quadrant. And as you see, when you will see a cosine theta, like constant times a cosine, always is placed in the first and the fourth quadrant, because cosine is positive in the first and the last quadrant. That's we can't plot the points. And the coefficient a will be this value. And that means the center will be like a half of a, respectively on the x-axis and the y-axis. That means what is also quite important, drawing and polar curves, when cosine, you will probably see more values or more intersection on the x-axis, because the x-axis represents 0 degree and 90, let me say pi. Okay? This is pi over 2. This is 3 pi over 2. Because cosine at 0 is 1, cosine at 180 is -1. That means we can place on the other side. That means that's always the case. Sine function actually at 0 and at 180 is 0. That we will never have any intersection on the x-axis if sine is involved. I mean, depends if it's shifted, maybe, but in this case. Okay, that's the circles. Let me put one slide above. What about these shapes? Do you remember from yesterday? we do have a beautiful shape, which I call like a heart, but we have a more Latin name, like a cardioid. Do you remember from yesterday? That's cardioids. My writing is, okay. That means, again, let's try to match, because maybe I can ask similar question. Let's say A, B, C, D. 1, 2, 3, and 4. That means, first of all, based on the equation, I don't want you to memorize stuff, but we have to have a little bit of feeling. That means if you will see an equation, A plus or minus B sine theta, or A plus or minus B cosine theta. And now, if the coefficient A and B are identical, always is a cardioid, always. Okay, that's always cardioid. And this, in my case, we have 1. We can see 1, 1, 1, 1, and minus 1 sine, plus 1 sine, minus 1 cosine, minus plus 1 cosine. Could be like 2 and 2, could be any number, but the coefficient A and B must be the same. That means, please remember, always will be that shape. Okay, and now, what do you think? A, do you think you can give me the formula for A? For the shape, for the graph A? Which one? First one, second one, third one, or the fourth one? The third one. I mean, definitely we can see we have wider on the x-axis. That means A and B must be cosine. Let's look at C and D. Yeah, it's just the one value, which of course is this one, the coefficient A. That means C and D must involve sine, because it's less values on x-axis. Okay, that means who answer? Kevin answer and Odalis answer 3. And how we can check? Because we know that's 0 degree, that's 90, that's 180, and again 2 pi. That means let's see, 3, I believe it is 3. Cosine at 0 is 1. 1 minus 1 is 0. Perfect. At 0 is 0. Cosine at 90 is 0. 1 minus 0 is 1. We do have 1. Excellent. Let's check pi. Cosine at pi is negative 1. 1 minus negative 1 is positive 2, because this should be actually positive, because we don't really have negative values. Okay, the distance on pi is 2. And 3 pi over 2 is 0, 1 minus 0 is 1. Perfect. And the situation at 2 pi is the same at 0. Excellent. This is 3. And this one must be 4. But you can see what I did. I only check not all of the angles, only the main one. 0, 90, 180, 270, and 360, of course. You get back to 0. Okay, 3 and 4. Okay, who can tell me C? Because it's enough to guess C, and then D will be automatically selected. C, which one? The second one. Let's see. Sine at 0. Sine at 0 is 0. 0 plus 1 is 1. Okay, great. At 90 is 1. 1 plus 1, 2. Excellent. I'm looking at this formula. Sine at pi is 0 again. 0 plus 1 is 1. And sine at 3 pi over 2, because that line represents 3 pi over 2, is negative 1. 1 minus 1 is 0. Excellent. Okay, that means you're good with cardioids. And this one must be number 1. Okay, that means that's another shape after circles. Then we do have a cardioids with the loop. Do you remember that shape? And we call, I think it's the French name. I don't know how to pronounce it. It's Lima cons, sounds like some up, yeah. Lima cons, line, yeah, let's say, I always call cardioid with the loop, okay? And we can see the equations. Actually, the equations should be a little bit nicer. Oh, I think I draw it. Let me check. Oh, this one actually looks better. It's the same thing, but I did draw it, this one. Okay, that's mean cardioid with the loop, okay? We can see the equation looks actually similar that I just gave you for the cardioid, A plus or minus B sine or cosine. But now what is important? Coefficient B will be always greater than A, always. Yeah, that means the coefficient in front of the trigonometric function is greater. And as soon as it's greater, we do have this loop like pushed out of the, because the values is telling me to do this. That means that definitely they are not the same. We can see A over B will be not the same. And I kind of wrote this way, but this is the same thing. B is greater than A. Okay, that means if you will see this equation that B is greater than A, you have to know, okay, cardioid with the loop. Or Lima and kind of like Lima songs. Okay, and now let's do the same. You can match A, B, C, D. 1, 2, 3, 4. Okay, who can tell me A? The shape A corresponds to which equation? Okay, if it's too fast, what we can do? 4, okay, I can, yeah, let's double check. Kyrie, probably, but what I will do, maybe let's answer this question. Can you see the x-axis? It's a little bit, that's the x-axis. That means the graph A will correspond to the sine function or cosine function? What do you think? The graph A. Can you see the difference? A has not many values, has just the one value on the x-axis. But let's look at B. B has the value 3. That means as soon as it's wider on the x-axis, more values than probably cosine. That means it looks like A and C will represent sine function. Okay? Will correspond to this equation with the sign. B has more values. Yes, we can see 3 on this side. That means B and D will go to cosine. Okay, and we did have the answer. Kyrie said 4. And let's see. I will highlight 4. And we can check 0 degree. Sine at 0 is 0, 1 minus 0, 1. Works. 90. Sine at 90 is 1. 1 minus 2 is negative 1, and we can see this represents 90, but negative 1 means that I will draw on the opposite quadrant. Perfect. And then 180. Sine at 180 again is 0, 1, perfect, and 370, which is 2 pi over 2. Sine is negative 1. 1 minus 2 times negative 1 is positive 3. Excellent. That means I matched all of the points. This is definitely number 4, which, as I said, number 2 will go to this one because it's sine. Okay, and whichever, can you tell me the graph B? The graph B, which equation? Plus 2 cosine theta or minus 2 cosine theta? You can check values. It's 1. Okay, we can see cosine at 0 is 1. 1 plus 2 is 3. Excellent. That means that's it. Let's check 90. Cosine at 90 is 0. 1 plus 0, it's 1. 180, it's negative 1. 1 minus 2 is negative 1. On the, we can see instead of here, I'm drawing the point here. And then for 370 is 0. 1 plus 0, it's 1. Okay, and then we get back. Excellent. That means this is 1, and this must be 3. Okay. That's actually the main shapes. That means now we can use them and possibly get, oh no, we do have one more. Oh, this one. Did you learn some of them? Probably not all of them, but I can tell you the trick. That means you definitely know, let's say 1, 2, 3, 4, 5, 6, 7, and 8. Okay, that's what about number 1? Do you remember the formula from yesterday? 1 and 5. Yeah, this is the shape that we should know. 1 and 5. Who remembers 1? No? Okay. Of course, you don't really have to answer. I mean, I love when you're answering the question. And of course, I love when you're attending the session. Oh, even and yes, Kyrie, that's the good yes. Yeah, that's good point. That means, let's see, all of them, you will tell me in a minute, probably you will tell me the equation for each of them. I know, because you are smart kids. I know you I learned you for a few months. Okay, that means all of them has these formulas, sine of n theta or cosine of n theta. Let's now, first of all, distinguish the difference between sine and cosine. You probably remember, right? Sine at 0 and sine at 180 is 0. That means and 0 and 180 is simply the x-axis. 0 and 180. That means as soon as we see some points on the x-axis, can you see? I see the point, I see the point, I see the point, I see the point. This will be cosine. Okay, as soon as you see some value, some intersection. Can you see the intersection on the x-axis for number 5? Do you see no? Do you see the intersection for of the x-axis on number 6, 7, and 8? That means as soon as in no intersection, this means the value for 0 and for 180 is 0. This must be sine. Okay, let me remove because I want you to tell me again. That means you know the difference, sine or cosine. Now the n value. Yes, Kevin. Yes, I know. It's nice pattern. Okay, now n. Yes, Rin. Everybody's writing something. Wow, that's nice. Okay, now the n. I think somebody said the even. Yes, that's me now. If the quantity n is an even number, like let's say sine of 2 theta, sine of 4 theta, or maybe cosine of 6 theta. That means when number is even, we will always have to double number of loops. That means if I see sine of 2 theta, number of loops of my flower will be 4. If I see sine of 4 theta, number of loops will be 8. If I see a cosine of 6 theta, number of loops will be 12. Okay, that means even number, we double for the graphing. But if we see the odd number stays the same. However, I can tell you a little secret. If it's the odd number, like I can write somewhere sine maybe of 3 theta, we kind of double also, but what we do, we trace the same loops because they kind of overlap. They are so symmetric in the middle. But visually, practically, when I have to draw it, if I see the odd number, it's the same, stays the same number. If it's sine of 3 theta, I will see 3 loops. 5 theta, I will see 5 loops of my flower, and so on. Okay, roses. Yes, actually, Kevin, I can call roses. It's a beautiful. I can even write this. That's roses. And how do you say the loops? Pedals, puddles. I know that my puddles. I think it's the. How do you say the loops of the flowers? Puddles. Okay. Pedals. I don't know. Yeah. Okay. I will call loops. It's just easier for me. Thank you for telling me the English words. I kind of knew, but okay. Yes, great kids. Okay, that's me now ready. I'm gonna ask you. You have to type really fast. Actually, I can keep. No, okay. I will remove this. That means you know how to distinguish. Yes. Really good, Kevin. That means you know how to distinguish the difference between sine and cosine, and even number of loops or odd number of loops. Yeah, or hang on, like, I mean, either way, even number in the equation or odd number in the equation. Okay, that's me ready. We will start with number 1. What is the equation for number 1? Flour. It's excellent. It's definitely cosine and is 2 theta because the number of loops double. It's 4. Excellent. Number 2, it's definitely cosine. Excellent, because we can see, I can maybe write these points. We do have points on the x-axis. Cosine, and we have 4, we have 8. This was double, 4. Excellent. Number 3, yes. Oh, Kyrie, who said sine? Can you see we still have values on the x-axis? Yes, that means no sine, because sine at 0 is 0. That means it's cosine, and it's this. Excellent. Number 4. What is number 4 equation? It's still cosine 1, 2, 3, 4, 5. If it's odd, we're just writing the same number. Excellent. Okay, number 5. Number 5 is, yes, it's sine, because you can see no, and we double, it's 2, it's 4. We do not have any intersection on the 0 and 180, which I call x-axis. Okay, because we know why I call x-axis from the old Cartesian coordinates. Okay, what is number 6? What's the equation for number 6? It's definitely sine, and it is 4 because we double, and it is 8, 4 and 4, 8. Excellent. Number 7, it's sine. I should mix sine and cosines, but it's okay. And number 8, 1, 2, 3, 4, sine theta. Yes, you see how many equations you know? Oh my gosh, you excellent. Yes, okay. That's me now, whatever flower somebody will draw for you, you know, yes, you will know the equation. You can draw a flower, and whichever position you will place, yeah, if it's nice horizontal, it's always cosine. Yes, yes. Okay, I like this. Yeah, that's me new, yeah, nice polar bear, rounded shapes. Okay. Okay, that means probably I should start section 10.4 now, but before I start, I will still give you hard time. Now, oh, okay, this is like another 2 equations, but I will not go like deeper in this one. As soon as we like have the square, we have to remove the negatives. That means please just remember. Okay, yeah, it's kind of like a symmetry. I mean, Kevin, you asking, yeah, no, for this one, I just want you to remember that if you have r squared of cosine of 2 theta, it's kind of like a half of this flower. R squared cosine of 2 theta is half of this. Because I'm not gonna go in the even, odd, and the other one, it's too complicated. We just want you to know this one. But I also have, oh no, where's my, oh, okay, 2 multiple choice questions. And then we can start section 10.4. Okay, who can tell me the answer? Maybe you can see question like that. Now, after all of these equations, this is probably really easy. Identify the curve described by r equals to 1 plus cosine, 1 plus 2 sine theta. Okay, I see some answers. Kevin says A, Kyrie A, Rin A. Okay, that means, yes, everybody? Who we have in the classroom? We have Natasha, we have Alisa, but I don't, yeah, I'm not forcing people to answer. Okay, that means I can definitely, Natasha, say A. Okay, Abhi, say A, okay. Because we can definitely see it's 1 and 2. That means I am removing this, this, and this. Gone. It must be a cardioid with the loop. And I can see sine. That means this is too big. That's too wide. This is the answer. Yes. By elimination, we can get A. Excellent. And I have one more. This one. Identify the curve described by the equation 1 r equals to 1 minus cosine theta. Oh, A, B, C, D, E. B, okay, yeah, I think the option, okay, first of all, it's 1 minus 1 cosine. That's not a loop. That's not a Lima sum. This one, A and B are wider on the x-axis. That means this is not the case. B, do you think it's B? And now I will actually check. Okay? I will check the values. Cosine at 0 is 1. 1 minus 1 is 0. Oh, that's mean, yeah, this is probably B. Cosine at pi is, at pi over 2. Cosine at pi over 2, it's 0, 1 minus 0 is 1. Cosine at pi is negative 1, 1 minus negative 1 is 2. And then again 1, because will be 1 minus 0 and getting back. Yes, that means this is the correct answer. Yeah, you probably know if theta is 0, radius is 0. If theta is pi over 2, pi, 3 pi over 2, and 2 pi. 1, 2, 1, and again 0. Of course, everything for this equation. And that's what we can do. We can only check the main angles. 0, 180, I mean 90, 180, 270, 360, of course. Okay, yeah, good. Yeah, let's actually do a few. Okay, we still have half an hour. We can make it. Or even longer. I can keep you even longer. Okay, and I think that's everything what I had. Okay, that's me now. What we will do, don't worry for the length. We will just cover the areas of the region bounded by polar curves. And we know the polar curves. That means, first of all, let's start with the, with the formula of the sector of the circle. I don't know if you remember this, but that's the sector, part of the circle we call sector, right? Like if I will draw the entire circle, no, I'm not gonna draw it because it's too big, but this will be the formula. 1/2 radius square theta. Probably you think it's like so weird, but okay, can you tell me this? Do you know what's the area of the entire circle? If we have the full circle, what will be the area? Yeah. R squared. Oh no, just, yeah, if we have just the whole circle with the radius r. I'm just asking really middle school, pi r squared. Pi r squared. Excellent. Right? But we can see this is the formula for the entire circle, and r squared. Yes, I'm trying to just make a sense of that formula. Always we will square the radius. That's actually, yes, I'm not gonna really, yes, go deeper in this because we will need another like half an hour. Pi r squared. Yes. One thing, yes, yes, okay, that's good. I thought, Kevin, that you kind of used the polar, like, terminology, let's say. No, okay, good. And we can see this formula, it's for the whole circle, which corresponds to 360, which actually I can write 2 pi. Yeah? That means this formula corresponds to 2 pi, the whole circle. What about, what will be the formula for, what will be the area of the half of the circle? Can we simply say pi r squared over 2? Of course, I can take the entire formula, pi r squared over 2. And now half of the circle corresponds to the angle 180 pi. That means, let's see what's happened. Okay, whatever angle I have, yes, whatever angle I have, always this one in the formula, it's half of them. That means 2 pi, it's 2 pi over 2. If half of the circle corresponds to pi, in the formula I have half of this. That means now, when I have a sector, with the random angle, Okay, and I would like to find the area. I will take the angle and divide by 2. That means, can you see that is the same thing? It's just the angle, divide by 2, and times r squared. Okay, that's it. 1/2 r squared theta. I just type differently. That means even if you will forget, you can go step by step. But I hope you will remember. Half of the angle times r squared. Okay, that means, but this is the sector of the circle. And of course, sector of the circle has the nice round shape here, which means distance from that point to the edge is always the same, r, 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 right? If we will take just the random polar curve, let's look at this one. It's not always as easy and as beautiful as the circle. I kind of see this like a sector of the circle, but not really, because the distance from the origin, from the pole, it's not always the same. It's like it's a little bit wider here, a little bit longer, and then the radius is shorter, shorter, longer. And this is the polar curve, yes, whatever curve we will have. Cardioid, limaçon, the rows. So, I mean, we may have a circle, but then we don't really need formulas. Okay, but hopefully you remember from Calculus 1 the definition of the integral, because we will try to use that. And we will try to use approximate this region by the sectors of the circle. That means, let's see. I will take the same thing. It's the polar curve, bounded from the angle A to the angle B, and I'm kind of like dividing by sectors, but each of them I'm making a nice, yes, the no, don't worry. This is, I can give you the final formula. You can, theoretically, you can skip this 10 minutes of my talk, okay? Because I have to, I want to tell you, I don't want to give you just the basic, yes, I mean, just the dry final formula, just a little bit. Maybe somebody will switch for the math major. That's my hope. No, okay. That's it. Don't worry. Looks, I know. Looks, oh, don't know. You, okay. Okay. That's really happy. It is interesting. Good. Okay, that's what I did. I'm trying to approximate first. That means this is one of the sector of the circle, and I know how to find the area of this. Just 1/2. Yeah, I can say 1/2 radius squared, and I need angle. Okay, and I kind of like type. Kevin is asking if we have to type the formula. No, I will, yeah, if we copy, I will give you the final formula, okay? I will give you and I will say, that's the formula that we have to remember and apply. Okay, that means one of this sector has the area 1/2 radius squared. We know that the radius is defined as a function in terms of theta. And actually an angle will be like a, kind of like a, how can I say, thickness. Yes, the wideness of this. That means I need that whole angle, delta theta. That means my formula looks like 1/2 the whole function squared and delta theta. But this is only one. If I have to add all of them together, I will put the sigma notation in front. Okay, that means we can see 1/2 radius squared and delta theta. Delta, yes, like a thickness. That means that's angle. That's the radius, that's the 1/2. We know that's from formula. Sigma indicates that we're adding all of them together. That means from 1 to n. Let me come back. Like we're adding all of them. 1, 2, 3, and so on. Yes, we're adding all of these sectors. That means adding all of them, I have nice approximation of the area of the region bounded by the polar curves. Do you know what's the star of the, oh, it's just because it's from the, it's like a sample point, because we don't know like how, don't worry, it's just the theta that is given. This will be like, you will know this, and you don't even have to go deeper in the definition. No. Can you see suddenly everything is gone? Because that's the formula for us. Okay? But let me just let's just come back for 1 second, and we can see if I will create sectors for each of them, they kind of like, we kind of sticking, the region is sticking out. That means it's not a good approximation. The best approximation will be if this will be really, really thin, if we will have infinity many of the sectors. That means I want n to be infinity, which of course, if infinity is involved, is simply a limit. That means now, saying that n is infinite, goes to the infinity, let me hug this. Limit of the sum is simply an integral. Yeah? If we remember, if we don't, I'm just, yes, reminding you. That means limit of the sum is the definite integral. That we can see, in order to find the area of the region bounded by the polar curves, we have to integrate from A to B. A and B are the angles, okay? And we have to just integrate a formula of the function squared times 1/2. And we kind of know where this comes from. Because this is just telling me to integrate. Limit, of course, because we want infinity. Sigma, because we're adding all of them. And we know all of these parts. Okay, that means this, the final formula. Do I have the other? Yes, I do have this slide for you. That means, as I said, maybe you can ignore the last, I don't know, 8 minutes, because probably wasn't even 10. Okay? But this is the final formula that we're gonna use. Integral from A to B, 1/2. Do not forget that 1/2, because I know that sometimes is the mistake. R squared d theta. And R, of course, is the formula that we will have. We know the formula for cardioid. We know the formula for limaçon. We know for the rose, for the circle. Yeah, okay. That means probably this is not gonna be a problem. Sometimes to determine the bounds, A and B, will be maybe the challenge, but probably not. Okay, that means let's solve few problems and we will be done. That means that's important. One more time. This one we have to know. Don't worry for the other theoretical part. Okay? If it's interesting, I'm so happy, but we have to know this. Okay. Oh, okay. Well, Kasia, too fast, because I thought that I have one more thing. Just in case, if we have to find the area which is bounded by 2 polar curves. And probably it's the same, yes, it's the same idea. Okay, Kyrie, it's okay, I understand. Thank you for being even, yes, for attending. Like, yes, almost, or more than half. Thank you, okay? Good luck at your last, yes. Good luck at your next class. Okay, that means this is like another thing. If we will have a region bounded on with the bigger longer radius, and then the shorter one, we can see the longer is represented by function f of theta, and the shorter by g of theta. That we simply have to make a difference. We have to take the longer formula minus the shorter one, and this will look like, okay, actually it's this one. We have to just copy the same formula, but we will actually subtract. Actually, hang on, because the area will be an integral from A to B, 1/2 r squared minus 1/2 another r squared. And let's say this will be the longer, the first one, and this will be the second one. Actually, I'm kind of longer and the shorter. This is the second one. Okay, that we can see. We have to follow the same formula, 1/2 r squared, 1/2 r squared. But this one, it corresponds to the longer radius, and this one minus the shorter one. Longer minus shorter, we will just get the difference. I mean, we will just get the area between. Okay? And my next slide is showing this, but looks maybe the typing kind of like looks too scary. But we can see 1/2 r squared, which is f function, d theta, minus 1/2 g squared d theta, which of course is the other one. First one, second one, first one, second one. And 1/2, since 1/2 is for both of them, the coefficient, I just put it outside. Okay, that means just square the first function minus square the second function. The second function always is the lower one with the shorter radius. Okay, now I think we can start. Let's solve a few questions, probably the exam type question, and we will be done. Okay, let's see. Hey, my first question is, find the area enclosed by one loop of the 4-leaved rows, just one loop. And this is the equation. Even if I will not give you the graph, you know the graph. I know. Okay, did I type the solution? Oh, I didn't. I have the solution on the other side, on the other slide, but I will type it. I will write for you. A, B, 1/2 r squared d theta. Yeah, that's what we have to practice. 1/2, I can put the formula. R is defined by theta squared, but limits of integration. That means, what do you think? What are the angles that one loop is bounded by? I can probably, yeah, I didn't really cover, because I really gave you like a summary of section 10.3, but I didn't cover everything with these shapes. We know that this is 0, this is 90, 180, 270. That's, what do you think? What is this one? What is that angle? Yeah, it's simply, yes, that means it's kind, yes, it's x. I mean, if we think about the Cartesian, it's in the middle, it's y equals to x, but it's simply halfway between 0 and 90. It's 45. Yes, who said 45? That's good. Abi, I don't know if I'm pronouncing good. Yeah, that means simply positive and negative 45. That means I can put my limits. Do you think I can use some symmetry and I can simplify my integral? Do you think I can only focus on half of the loop and multiply by 2? 1/2, and then I can say from 0 to 45? Yes, but please remember, multiply by 2, symmetry, which of course 1/2 times 2 will be gone. And I have cosine square 2 theta d theta. And I can tell you, not all of them, but most of the question for this section, we will only ask you to set up an integral. Okay, maybe this one is good because it's kind of like testing another thing. If you know how to integrate, this is of course a little bit of chapter 7, how to integrate this function, but the most important thing is the setup of this integral. Okay, how did we get the 2? Yeah, okay, can you see, because can you see the limits? I did change the limits of integration from 0 to pi over 4, from 0 to pi over 4. That means this integral with these limits represents half of the loop. Yeah, then I have to multiply by 2 to cover the other half. Yeah, that means that's the blue 2, not Bluetooth, blue 2. And 1/2 is part of the formula. Always 1/2. And of course, 1/2 and 2 is gone. And I can show you that's the full solution. Okay, I even have this. And you can check how to integrate this, and that's the final answer. Okay? Because we will not spend time of integrating. You know how to integrate. I can probably, but no, you know, and we do have in, yeah. So Do we have to know how to? Yes, you still have to know, because even not for this week, but for the final week, oh, definitely cosine square of theta, sine square theta, we have to, yes. That's when we have to know. We're just using the half angle formula, if you remember. But I can tell you, I can double check. You can see for most of the question, we're just asking you to if it's easy integral, we will just ask you to set up an integral. Okay? I maybe have some multiple choice and I can show you. Okay, that means don't worry too much for the integration. Okay, I really want you to get the formula, to know how to set up. Yeah, like this is important, how to apply and find the angles. Okay, let's keep moving. Okay, the next question. Find an area of the region that lies inside the curve r equals to 1 plus sine theta, which I draw this one, and outside the curve r equals to 1, which I don't have it. I will add. Do you know what is that curve? R equals to 1? It's just a circle, exactly, with radius 1. That means I can add maybe that circle. Oh, I don't know if I'm good. Oh, let's say that this is the circle. Okay, that means this is r equals to 1. This one is cardioid. Everybody can do this. And now what they want? They want inside the cardioid and outside the circle, which I believe, what color shall I pick? Maybe yellow. Is that part. Okay, is this part. That means what we can do. What we need. Did I type? No, I didn't type the solution, even better. Integral from A to B, and since I am involving two curves, let me write first one, and this will be the second one. R's 1/2. 1/2 r squared, 1/2 r squared. The first one and the second one. D theta. Okay. And I can still put 1/2 possibly outside, 1 plus sine theta squared minus 1 squared d theta. Oh, my d is crazy. Question marks, of course, because that's what okay, that means everybody agree what I did? Even this one looks funny, 1 squared, but what I'm doing, I'm showing to my teacher that I know the formula. Okay, that's you can see how nice it is. And I can tell you, for this type of integral, we will, even if it's easy, we will never ask you to integrate, because we really like to see, like, where is the difference? Which function is the top one? Which function has the longer radius? That's, we really like to see this. But we're still missing the blue question mark. Do you possibly see from the graph what will be the limits of integration? Looking at the yellow region, for what angle the yellow region is started and for what angle is like ending? And you see this is, it's from, yes, it's from 0 and actually it's going all over to pi, exactly. But what we can do, we will still, because these points we call points of the intersection. That's when I can say points of intersection. 1 plus sine theta is equals to 1. And if I will solve this, this is on my left hand side, I put one curve, on the right hand side the other. It's 0, and sine for what angle is 0? Of course, for 0 and pi. That's what we can see, from 0 to pi. That if, just in case, if maybe your graph is not clear, but we can see on this one is so easy. That means 0 and pi are the points of the intersection of these two curves. One more thing. Do you think I can rewrite this using a symmetry? How can I change? I will not change my formulas. That means this 1 squared, 1 squared. Okay, I can remove this too much, right? You're too good for this. That means I will still have 1/2 for now. And what do you think? If I will use the symmetry, because we can see how the yellow region is nicely symmetric, how my limits of integration will change? Who can tell me? What new limits? From 0, right? From 0 to halfway. And what is missing? What is missing? It's, yes, that magic blue. Not Bluetooth, Bluetooth. Okay, I know. That's what I kind of, Bluetooth is missing. Yes, that means do not, if you're using a symmetry, don't forget Bluetooth. That's actually, I didn't plan this, I promise. I didn't plan it. It's live, it's really live session. Yeah. Okay, and if you will see the option, of course, I will rewrite without, right? Because I will just, this will be your final answer. 1 minus, okay, that means 1/2 times 2, 1/2 my, times 2, of course, is 1. Okay, I mean, what you're writing, 1 plus sine theta plus 1. Oh yeah, oh, that's pretty. Factorization, elegant, yes. But no, I will probably, that's what I want you to do. And don't worry for integration. Yeah, just the settings. Okay, that means this is not easy question, I can tell you. Yeah. Okay, let's see next. Yeah, but Kevin, really good algebra. How can I say, intuition. Bluetooth, I do know, I also like the Bluetooth. Don't forget on the test, yes, don't forget. Because always, yes, always look, maybe I can always look what is the number here. If it's like 1 or 1/2 or maybe 2, you know what it should be. Yes? Especially when you're using symmetry, probably it's nothing. Okay, what I have next? Oh, this is just the same thing. I was just saving extra space. And, oh, okay, this is similar. Okay, let's set up. Oh yeah, we did sine. Okay, that means that's kind of similar. Find the area of the region that lies inside this. Oh, I like red. Okay, inside 2 times cosine theta and outside this. That means I think we do have, okay, what is the first shape? What's the first one? Do you remember? I think the very, very first slide. We have just cosine with the coefficient 2. That means it's a circle. But it's the circle which is placed, let me see now, that's different. Okay, I don't have the graph. It's, yes, it's the diameter 2, really good. That means it's the circle which is placed a little bit too flat in the first and the fourth quadrant. Oh, terrible. Okay, that's 0, that's 90, because we are in the polar coordinates. Okay, that means this is 2. I'm sorry, a little bit, but it is a circle. That means this is the first one. What about the second one? We have this, yes, r equals to 1. It's just, maybe I can use different color. Actually, this is 1. That means, no, it should be smaller. Oh no, the diameter is 2 for both of them. That means the size-wise, they are the same. Oh, my circle. Yeah, I have to take part of the competition, like teachers are drawing a circle in the classroom, like live. Okay, looks not bad. I still have to save points of intersection. Okay, let's take my yellow pen. And then, yeah, looks like a Venn diagram. Yes, because we do have the middle part. But which part we're looking for? Which region? Inside the red one, and outside the dark blue. Where am I? Inside and outside. Ah, okay, that means similar. Yes, similar to that we just did. Okay, we're looking for this. We really have to find that angles. Let's say A and B. Because they are bounded, the yellow part, the yellow region is bounded by these two. Okay, that's what we know. We know this. Integral from A to B, 1/2 r squared, 1/2 r squared, minus, of course. This one is 2 cosine theta. This one is just 1. But who can tell me? I will put the first one and the second one. Which one is the first one? Which one has the longer radius starting from the origin? The cosine to theta. Okay, that means this one is the first one, this one is the second one. Excellent. Okay, I can do this. 1/2 outside from A to B. I still have to find the first one is 2 cosine theta squared minus 1 squared d theta. Let me make smaller and bigger. Okay, this means I do have nicely the first curve and the second curve. Excellent. Okay, now limits of integration. Probably this one we can't easily guess, but we can compute points of the integration. Where can I squeeze? Points of intersection. Points of intersection, not points of integration. Okay, the first one must be the same like the second one. 2 cosine theta, it's equal to 1. I think so, right? That means cosine theta, it's 1/2. That means cosine, for what angle is 1/2? We can see, yes, Alisa, and yes, Kevin, and who was, yes, it's pi over 3. That means this one, it's pi over 3. And this one we can say, oh, hang on, pi, yes, we can say 5. Or maybe I can say this. Okay, because we also, yes, we will need the smaller value. We always, yeah, I mean, it's kind of like the same because we will use the symmetry anyway. Okay, that we do have our points. You actually helped me. I really like this. That means what we have. We do have 1/2. Oh, actually, I can place here from negative pi over 3 to positive pi over 3. Excellent. But now I'm changing my limits of integration because I like you to use the symmetry. 2 cosine theta okay, and what new limits of integration we will have? And we will have the blue 2, of course. I'm multiplying by 2 because I will focus on half of this. And yes, Kevin, thank you, just from 0 to 60, pi over 3. But actually, I will use the blue one because too many colors, but blue corresponds to the limits. Okay, and please do not forget about the blue too. Okay, that's pretty much. Let's see what else I have. I think I have a few more. Or maybe I can find a multiple choice, but that's pretty much what we like you to do. Yes? Put the curves, figure out like the position, figure out the points of intersection, and of course the formula. And the same thing, we will not ask you to integrate this. No, we just want the settings. Okay. Okay, I have this one, but probably it's too easy. I will skip this one because I did type the solution for you. Okay. Can you review the integration at the end? Yes. You mean, but what integration, Kevin? Specific function, because you know we did have the whole chapter 7. Okay, let me check what else I have, and I can even integrate the first function that we did. Like how to integrate after. I can do, yes. I know that you're thinking, okay, we can definitely integrate cosine square of 2 theta. Yes. Okay, this one I will keep it for you because it's nice settings. Okay, and I do have a solution. Don't look at the solution. You can try to solve it, and then okay, this one we will only ask you to set up. That's me. Let's just, maybe I don't have, oh, and I have multiple choice. Excellent. That's me. Let's see. Compute the area and close. Oh, compute. Let's do this one, because this one will involve computation. Compute the area enclosed by one loop, okay, of this weird shape, which, that's what I probably mentioned, you're probably reading between the lines. If we will give you this formula, we will provide the picture for you, okay, because this one is the r squared, is sometimes like, yeah, not, yeah, I mean, we know that it's just the two loops are removed, but we will give you a shape, the drawing. Okay, that's what we need. We need an area, which is 1/2 r squared d theta. This one is just one curve. We don't need to subtract anything. Should 2 cosine theta, but this is r squared. Yes, Abby, you're right. It should be another, yes, another, like another 4. If this will be removed, and of course we will not have this one. Yeah, yeah. That's, I know it's tiny. It is squared. Maybe I should remove it. Okay, it is squared. That's we just removing the negative parts, which probably the top one doesn't, but it is negative if we're looking at the graph. Okay, 1/2, and I will cosine 2 theta squared. Oh, actually, oh, no. Do I really have to square? Can you see that? Actually, yes, yeah, I don't have to square it. Oh, because this is the formula r squared. Oh, okay. Okay, that's, of course I did, yeah. That's, we do not, yes, we don't have to square it. Okay, limits of integration. That's, do you remember? Do you remember, was like, we did this limits. It's the same shape. That means these lines are the limits of the angle A and angle B, and it's exactly halfway between 0 degree and 90. That means you answered this question. It's just 45. Negative and positive. We're gonna use the symmetry. 1/2 4 cosine of 2 theta. Yes, it will be from 0 to pi over 4. And we have to remember, oh no, I like the Bluetooth from 0 only, you can see, from 0 to pi over 4. Excellent. And let's, oh, this one is not squared, but I will still solve the squared function. Okay, that's what we have. We have an integral. 1/2 times 2 is 1. 4. Okay, who can tell me an integration of cosine of 2 theta? Integral of cosine of 2 theta. Do you remember? It's sine of 2 theta, because derivative of sine is cosine, but we still have to divide by this coefficient. Okay, sine of 2 theta over 2. It's kind of like opposite to the chain rule. Derivative of cosine of 2 theta, of course, will be negative sine 2 theta times 2. But this is antiderivative, we dividing by 2. And from 0 to pi over 4. 4 and 2 we can cancel out. Okay, and then we have 2 sine of pi over 2 to sine at 0. Do you know where the sine over 2 come from? Oh, hang on, Alicia, I'm not looking. Doesn't sine to theta becomes 2 sine cosine? Ah, actually, if we would like to use the double angle formula, of course. Yeah, that's also good, yes. Good seeing. Yeah, but I think we do have some integration. You'd probably remember really good from chapter 7. We have to use the double angle, especially for the trigonometric substitution. But I think we can just substitute pi over 4 and multiply by 2. Okay, but good. We can just keep it like that in this case. But it's really good that you actually know the formula for sine of 2 theta. It will be definitely on the test, but this one we can keep it. Okay, 2 times pi over 4 is pi over 2. Actually, what is the answer? Am I getting right answer? Okay, okay, it is 2 times 1 minus 0. It is 2. Hang on, did I forgot 2? I mean, no, I do have my Bluetooth. That's what, this is gone. I have 4 and 2 is 2. Okay, I think it's, yes. Yes, good, good. I think the answer is 2, which means half of the loop is 1. Yeah, I do have. You can double check. I'm just trying to go through. No, I think it's correct. Okay, that means what I do, I will still solve the first integral, the cosine square of 2 theta, but let me, 1, 2, okay. That means I have 2 questions. We don't have to look at the other. I question 1, which we probably did. Okay, that means that's what you will probably see on your quiz and the final test. Set up, but do not evaluate an integral expression for the area inside the curve r equals to 1 plus sine theta, and outside the curve r equals to 3/2, which is just a circle. That means, do you think I will try to do it? And maybe you, if you have a pencil and the paper, you can try to do it. What we can do? I don't know if this is too small. Okay, that means we do have this one. 1 plus sine theta. Do you know the shape of this curve? It's the cardioid or limason. I don't know. I'm not. It's the cardioid, big cardioid. Thank you for typing. That's kind. That means the cardioid, and we have to just think which way, because of course we don't really memorize. That means this is, I can write down. It's a cardioid. Okay, and I can try the angles 0, 90, 180, 370, 2 pi. Okay, sine at 0 is 0. That's when we will have 1. Sine at 90 is 1 plus 1, 2. Sine at pi is again 0 plus 1 and negative 1. Okay, that's when this will be this way. Let me move my 2 here. Okay, 1. Oh, could be. It's okay. And then this is 3/2. That means this one will be wider. It's the circle with the 3/2. Oh my gosh, it's not really a circle. because my ones, okay. 3 halves, 3 halves, 3 halves, and 3 halves. I'm really sorry, it should be nice blue round circle. And what we need inside the cardioid and outside the circle. We practice this a lot. That means that's the points of intersection A and B. Points of intersection, 1 plus sine theta, it's equal to 3 halves. Sine theta, it's 1/2. Sine for what angle is 1/2? Who can tell me this? Sine for what angle is 1/2? Oh, pi over 3? Kevin? Can somebody confirm or correct? Okay. Yes, pi over 6. Pi over 6, excellent. That means this is pi over 6, and this will be the 5 pi over 6 because it's the reference angle, the same distance to the x-axis. Excellent. Okay, that we do have everything. Can you tell me what is the answer? Which one is the correct one? We almost have everything given. What do you think? It's answer A. Let's see the top. The longer radius is the red one, the cardioid. That means cardioid minus the circle. And the limits of integrations are from pi over 6, theoretically to 5 pi over 6. But we can cut in the middle. A, okay, I see Odalis is saying A with the question mark. Kevin is saying A. We have cardioid minus the circle, and it's from pi over 6 to halfway, to pi over 2, and 1/2 is gone because the Bluetooth, it make it gone. I think so. Do you, everybody agree? Oh, everybody agree? I will circle this. Let's say B is wrong. C looks good, but no, oh no, not pi over 3. That's the mistake. Oh no, D is wrong, and E is wrong because the other way. Natasha is saying A too. Okay, I think it is A. Yeah, you see, that's the way to, yes, to figure out, to take time maybe to draw it. If you can draw nicer than me, but I think this is still decent. Points of intersection, yes, do not make the mistake, but probably you will not. And then figure out your formula, really good. Extremely good. Okay, I do have one more. Do you think, would you like one more? And then me solving integral, or it's too long? Okay. Of course, you don't want to say, yes, one more. Brave enough, Kevin. Good. Okay. What about this one? Which integral represents the area which lies inside a circle and outside a cardioid? I did tell you. Okay. What I need? I will need cardioid. Oh, which way is the cardioid? Cosine, I'm just trying to focus on this one first. Cosine at 0 is 1. 1 plus 1 is 2. Cosine at 90 is 0. Then it's 0 plus 1. Cosine at pi is negative 1. Then I will come back to 0 and then 1. Okay, that's mean my cardioid will be, let's say, 2, 1, and 1. A little bit too tiny. Okay. And what about the first one? I mean the first one in the question. Oh, I can't box it. 3 times cosine theta. That means this is just a circle with the diameter 3. Right? Somebody said this before. Oh, I can use this as a 3. Okay. Not perfect, but we know what we're doing. And where is my yellow pen? Inside the red and out, oh, no. Inside the blue, outside the red. Okay, typical. You probably know the answer. Do you know the answer? We will need that angle, A. We will need that angle, B. No, that's A. That's B. Or is the answer D? That means we can see the blue curve, it's longer. That means definitely, oh yes, no, not A, not B, not C. Because the blue curve, that means I will square the blue one minus the red one. Okay, and what about the limits of integration? Points of intersection. 3 cosine theta, the same, like 1 plus cosine. Subtracting cosine and dividing by 2. Cosine for what angle is half? Of course, pi over 3. That means this is pi over 3. Oh, not negative. This is negative. And this will be negative. But we can cut it through, cut in half. Okay, we can focus on half from 0. That means from 0 to pi over 3, the blue curve minus the red one, which I think Kevin was right. Everybody can still look at this and possibly correct us. I'm just double checking. From 0 to pi over 3, 1/2 is gone, right? We remember 1/2 times 2. It's gone, of course, because that 1/2 is important. Okay, yeah, we can see nice and easy. That means I hope you're gonna ace it this week, actually, as always. Okay, that means one more integral and we will be done, because I think we solved all of my problems, which is actually really good. What I need, don't worry for this. Oh, I need just empty slide. Okay, this one, maybe this one I will just use it slide. Don't worry for this. And what was the integral? Cosine square of 2 theta. And what was the limits? From 0 to pi over 4. Hang on, let me copy. Okay. From 0, that means that's not this question. From 0 to 45. Okay? That means probably you forgot, but in order to integrate cosine square or sine square, we have to use the half angle formula. That means 2 theta is the half angle. 1 plus cosine of 4 theta over 2. Okay? If this is sine square, the difference is minus, but always is cosine. Always is the cosine function for both of them. And we can see 2 theta was the half angle, which now I have to put 4 theta. Okay, let's see. I will put 1/2 outside, 1 plus cosine of 4 theta. Let's integrate. Okay, 1/2. Integral of 1 d theta is just theta. Okay, and now who can tell me integral of cosine of 4 theta? Who can tell me this? We did this today, do you remember? It was cosine of 2 theta. Cosine of 4 theta. No, it's just sine. Right, Kevin. Sine, hang on, positive. Odalis, yes. Sine 4 theta over 4. Because I know we always please take like a few seconds like more. You can always differentiate back. Derivative of sine is cosine. That means I don't need any negative numbers involved. Okay, let's do it. Pi over 4 plus sine at pi over 4 and then minus 0 plus sine at 0, which of course is 0. I did substitute the upper limit and the lower limits. That's 0. What is sine at pi? Sine at pi is actually 0. Ah, okay, pi over 8. It's the final answer, which I think it was pi over 8. Okay, I'm just checking myself. Okay, that means I can promise if you have to, for this of course section, if you have to integrate, this will be probably the integral, the hardest integral. The other ones will be just sine, cosine. But I can tell you 99% of the question in this section, we asking to set up an integral. We're not asking to integrate because it's not really the concept from this section. Okay, that we will ask you to set up an integral. And you will see on the weekly quizzes. Just set up the integral. Okay? Okay, that means thank you very much. Excellent participation. Excellent. Almost like in the real classroom. I love it. Let me actually switch off. I'm still there. Yeah, maybe my hair don't look good because I was solving all of the questions, but thank you. I just love it. I wish more students will attend, yes, but it's still okay. I know that all of the students are watching the session because it's not yet. Thank you very much, and see you next week for the final review. Okay, I will bring some surprises for you. Thank you.